Welcome, everyone. I'm going to start with a story of how we really got launched. We already had started building the airplane, but we had an unusual way that we got basically thrown into the air a little bit before maybe we were ready. So this is a picture of Linux Foundation Executive Director Jim Zemlin. I don't know how many of you know him. It was taken, the next series of slides were all taken. I was sitting in the front row of the opening keynote at the Linux Foundation Member Summit in March in Napa, California. And we were already working on the first-person project. We'd already started talking with Jim and his team through LF Decentralized Trust. And they'd scheduled a workshop on the second day of the conference with Jim and his team and the LFX team that manages the LFX platform to really dive down into what were we planning to do together to address the digital trust issues that I'll tell you about. And so there were several of us there from the project. We're very excited for this workshop the next day. So we're sitting there on the front row of the opening keynote, and Jim, you can see the title there, Open Source Security, Trust, and Innovation, Rapidly Colliding Issues. And Jim starts into it, and the first thing he talks about is one of the biggest issues. I've already seen it actually on a slide earlier here today. Open source malware injection attacks. The best known being the XZ attack. This is actually a picture of the Wired magazine story about that attack. So I'm assuming with all of you in open source, you're probably fairly familiar with these kinds of attacks. Jim also talked about other challenges to open source development, including the fact that AI is now becoming a regular part of many developers' process and in some cases, AI bots are direct contributors to projects, which is okay if you actually know the provenance and there's accountability for that AI bot. But if you actually can't determine it's an AI bot or a person making a contribution, that becomes a real issue when you need to know the full provenance of the code being contributed to a project. So anyway, Jim starts into the story, and then he starts using slides that we've seen before that we know he's going to use in a workshop the next day, and we realize, oh, he's going to do his keynote on the first-person project. So we were, obviously we were excited about that. Anyway, Jim's point was, to combat this, we need, and by we there he meant all the Linux Foundation, in fact, all open source, regardless of where it's developed. This is a problem of the open source supply chain as a whole. And he had a really compelling argument. I'm not going to show you all the slides from that, but his conclusion was, to solve this, we need the kind of technology solution that we're developing at the first-person project. And he caught our key line there. We needed a way to prove the real people with real trust relationships working on these projects. This is one way of putting what's widely known as proof of personhood. And I'll talk more about that in a minute. He then referenced a slide that we had given him that referenced a paper. I'll have a QR code coming up for that later if you want to read it. It's actually very easy to find. If you just type personhood credentials into any search engine, this is the paper that comes up. It came out in August of last year. 32 authors of that paper from all over. Interestingly enough, 2 of them were from OpenAI. We'll talk more about the solution that they have, or they've been promoting for proof of personhood. But this was a way of saying, we can use verifiable digital credentials and digital wallets. That is the essence of what we've been working on for decentralized identity to solve this problem. And we very much agreed with that. We were already on that track. When this paper came out, it sort of supercharged our effort. And what really surprised us in Jim's keynote was not just that he was promoting all of this, but that he announced there in that keynote that the place they wanted us to start, was with the Linux kernel project. And that's a little bit like, a set of kindergartners finding out that they've just been assigned a postgraduate doctorate project. Like, really, you want us to start with the most valuable open source project on the planet? Turns out he had quite good reasons for doing that, and he had lined up Linus's number two, Greg Kraut-Hartman, to be at our workshop the next day, and that's who we've been working with directly, because he's the one that Linus basically assigns to take on looking at new infrastructure or tooling for the Linux kernel project. And then this is the last slide he showed. It's also one we gave him. And if you're at all familiar with the history of self-sovereign identity and the emergence of digital wallets and credentials as new trust infrastructure generally, and if you're here in Europe, you're probably hearing, how many folks in this room are generally familiar with the idea of the European Digital Identity Wallets Initiative? A couple, okay. What's that? It is based on, the legislation is widely known as the IDAS 2. Okay, are you putting me on? Or? No, not at all. I yeah. Don't know the things. Yeah, it really is the second generation. Yeah. Probably knows it very well. Yeah, no. It's, the IDAS 1.0 was, a major effort that really is widely considered to not have succeeded in helping with digital identity infrastructure here in Europe. And EIDAS 2.0 now is more widely known as European Digital Identity Wallets Initiative. Now, if you're a European citizen, the goal of that legislation and those projects is by the end of next year, your government, regardless of what member state you're in, is supposed to provide you with an option for a digital identity wallet which will accept a standard PID, personal identity credential, from the government, which you now are, by legislation, going to be able to use anywhere in the EU. And many places outside of the EU are very interested in this, new credential. I'm not going to go into that project in detail other than to just say it has, in addition to other countries such as Bhutan that's already adopted SSI and have their own national digital identity wallet, it is paving the way for the adoption of digital wallets and verifiable digital credentials as a new standard tool for digital trust. And I say that I'm from Seattle, I'm from the US. My country is way behind in this effort, and unfortunately falling further behind with the current administration that we have. It seems to be more interested in certain digital currencies. Yeah, exactly. In any case, in the area and I refer to it generally as decentralized identity. That's become the sort of accepted term every place. If you're a little bit more leaning into it, you call it self-sovereign identity or SSI. I'm co-author of a book on that topic, so I tend to prefer that. But in any case, regardless of the term, the key challenge we've had in that area is interoperability, okay? And as much as I like to say that the European Digital Identity Wallets Initiative is helping, it's having to make certain choices in that area that are, not necessarily going to be compatible with what is happening elsewhere in the world. And it's just a general problem as we work out how digital wallets and credentials are going to work. There's a lot of different interoperability challenges. With the first-person project, we said, okay, regardless of what everyone else is doing, if we're going to solve this problem of proof of personhood, and we're going to do it for any person, any place, and any relying party or verifier that wants to accept that proof and say, yeah, I need to know you're a real person, but I don't need to know exactly who you are. We wanted to say, we're going to standardize that, and that requires that there's certain capabilities of the wallets that support it. There's capabilities of the credentials that are needed. I'll talk about those, and the ecosystems that are going to support them. That's a term we use whether it is anywhere from a nation state to a company, to an association, to a church or a neighborhood, whatever. We call those digital trust ecosystems. And they're the ones that add support for these types of, for these credentials. Just the way in the EU, banks and stores and retailers and everyone are adding support for accepting the credentials from the wallet. All right, so I'll quickly describe what we're doing in the first-person project, and my goal is, in the next 20 minutes, is to give you enough of an understanding so then we can talk about how would that apply to the kinds of open source projects or infrastructure that you're dealing with here that we're hearing all these great presentations about. So, as I've already said, the essence of the project, when it started, was specifically to come up with a decentralized solution for proof of personhood. By the way, this whole slide deck it's Google Slides deck. I'm happy to share. I don't think I included a QR code for the deck itself, but there's a number of QR codes for the key things I'm referencing inside of it. Now, once we got it started, and the reason proof of personhood has become such an important topic is because of AI, but we also rapidly realized that the second goal of the project was that this infrastructure is how we solve the problem of proving that if you're using a personal AI agent, it's acting on your behalf. And at the very end, I will show you exactly how we propose to do that using the very same credentials and infrastructure we're talking about. So it doesn't go further into solving other of the many issues around AI, but if we can establish a foundation for trust in personal AI agents, which we're already being told is the same foundation can be used for enterprise AI agents, now you've got a way to support agentic commerce, agentic transactions based on this infrastructure. So that's the second goal of the project. It originated in collaboration between these 4 different organizations. As I said, I'm a member of Trust Over IP. I'll talk a little bit more about that. Of the steering committee, was one of the co-founders 5.5 years ago. We moved, once Hyperledger turned into LF Decentralized Trust, we moved under that umbrella. So we're now the one JDF Open Standards project under LF Decentralized Trust. We collaborate a lot with the Decentralized Identity Foundation, which actually started before JDF moved in, so it's outside of LF Decentralized Trust. And then some of the open source code, we collaborate with the Open Wallet Foundation because that's where implementations in open source of the standards we're creating are being done. And there's one specific project there, the Trust Spanning Protocol, that I'll tell you more about. So that's why we originated at the LF. And some of the member companies, I, for instance, have been at Gen Digital, which acquired Evernym, which is one of the leaders in the open source space, in 2021. And so that's how we got started. Everything I'm going to cover here today in much greater detail is in this white paper that's on firstperson.network, and that will take you right there. I will warn you, I strongly recommend it, but it is not your average industry white paper. It's 86 pages. But it's very readable. It's got like 45 diagrams, many of the things you'll be seeing here today. So that's a good place to go. These are the 10 sections in that paper. And I'm just going to condense it down to the essence of what you need to know to then sort of go, okay, how does the first person project, how does this new infrastructure apply to what you're doing? So I want to be clear, when we talk about proof of personhood, there are a number of ways and approaches to this. One of the best known out there uses a global biometric database of a certain kind, and you might recognize it through that biometric implement or whatever you want to call it. This is an iris scanner. How many folks do recognize what is the project that it's part of? I'm not seeing a lot of hands go up. A couple, okay. So the project is now called World. Initially, when it started, it was called WorldCoin. And it is Sam Altman from OpenAI is the co-founder of the project, which has an interesting story about it. Why would the co-founder of OpenAI be a major investor and backer of a project for proof of personhood? It's because he recognized early on that in the world of AI, if you can't prove a person is real, and therefore you don't know what's being produced by AI, it could cripple the AI industry. So he feels this is a very important problem to solve. And so he was an early investor in what's called Tools for Humanity, is actually the technically the name of the company behind it. They did their own analysis and said, well, the best way to solve this is with a standard biometric and basically a blockchain that would accept those biometrics and use them. They have a fairly elaborate privacy architecture behind it. You don't actually have your biometric on the blockchain. You have a hash of your biometric on the blockchain. And you receive a credential in a digital wallet that you can then use, and when you present it to a verifier, they check the blockchain to say, oh yeah, your credential is actually on the blockchain. You can only get one because the iris scan will check, and if you lose your wallet or something like that, you have to get re-scanned, but you're still the same person, and you get one credential on that blockchain. Besides just the privacy implications of having a single biometric, essentially database for the entire world, if it was going to work, it also uses a single blockchain with a single associated cryptocurrency controlled by a single company. Thank you. What happened when World came out, though, is it basically put the fear of God in a bunch of us. Wait a minute. What are we going to offer as an alternative? This is a real problem that needs to be solved if AI is going to be successful and many other things. But how are we going to do this without a global biometric database? Now, they went, the World team went to Vitalik when they were initially looking essentially for endorsements about of World and WorldCoin. And Vitalik did what he always did, and he wrote a 6,500-word essay. It's really quite good. But the essence of it, at the very end, he provides this summary, this chart. And that third column is what WorldCoin is. It uses a specialized biometric to solve the problem. And what Vitalik said is, actually, a social graph-based solution would be the best way to solve this. And as you can see, the decentralization would be fairly high, the security would be fairly high. What he was concerned about were privacy and accessibility or scalability. Now, Vitalik is going to look at this through a blockchain lens. And what he's concerned about is if you put a social graph on a blockchain, especially if it's a social graph of people, you're going to have privacy issues, okay? So when the decentralized identity community looked at the same thing and said, oh, you building a social graph of real trust relationships, but not putting it on a blockchain, putting it in decentralized wallets all over the world, well, we could actually handle that privacy issue. We could have very strong privacy, very strong accessibility and scalability, be very decentralized and very secure. This really got us motivated. They're like, hey, if you take this analysis, we can build this. We ended up calling this, what we're building is a decentralized trust graph. Now, if you're wondering, what does it really mean to have a decentralized trust graph? If I talked about, hey, social networks today, and the first things that come to mind, you think of these giant centralized databases, right? I mean, Facebook, for example, largest social graph ever assembled, right? There's a nice line about Facebook has assembled the social graph that the CIA would dream to have, right? So when you try to visualize, what do we mean by a decentralized graph, especially a decentralized trust graph? I think most of you in this room are carrying one of these, right? So think about it right now. How many of you on your phone right now have a mobile address book entry for someone else in this room? Put your hand up. In your mobile phone, you have a mobile address book. Do you have an address for someone else in this room? Okay. That's a decentralized trust graph, okay? It doesn't exist anyplace centrally, but you control who you're connected to. Now, if I turned around and wanted to ask one of you, well, can you connect me with someone else that you know there? How does that actually happen? I need to talk to you directly. I need to ask you for permission. You make a judgment about whether you trust me and making that introduction to another person. That is how decentralized trust works, right? That's sensitive information, who you know and who you would trust to make those introductions to. That's how a decentralized trust graph should work. All we're doing now is we're saying, hey, guess what? You right now couldn't give me a proof about who you know in that address. You could show me the address book. You could actually, call someone and say, yeah, that's really that person on the other line, right? But if we turn it into verifiable credentials in a digital wallet, now you actually can produce proofs against that. You can produce privacy-preserving proofs if you use zero-knowledge cryptography. That's what we're doing with the first-person project. If that high-level picture is enough, we'll go a little bit deeper just so you understand what are the components, and then we can discuss, okay, how would you actually use this, or how is the Linux Foundation going to use it? Go ahead.
Guessing you will get to that, but from the point of view of this basic principle, this is just a web of trust again?
Yes.
So I guess it's done better?
Decentralized web of trust. We're not trying to...
GPG web of trust is already decentralized.
Yes, you're right. In fact, we'll talk.
About to ask the same question, how is it different from GPG key signing? Key signing part is...
Perfect. That's going to take us right into the next part. Exactly. In fact, when Jim Zemlin gave his keynote, he used the example of saying, this is really like, basically a modern version of the PGP Web of Trust. And we'd heard that before, but not directly from Jim. So knowing we had the workshop the next day, I went to my hotel room and created the diagrams you're going to see to show exactly what we mean by, okay, this is a modern version of that Web of Trust. Okay, so I'm going to quickly cover, when we talk about decentralized trust infrastructure and decentralized identity, the basic building blocks for it, okay? This is a very, very simple high-level overview of what we call the trust over IP stack, okay? I think most of you in this room are familiar with the TCP/IP stack that gave us the internet, right? This 4-layer model. These 4 layers are, we're following the whole, trust over IP was started based on the premise, if we have a same 4-layer stack that we create on top of the existing stack, in fact, it can run over any transport protocol, but TCP/IP is the one, that our main target. If we design the 4 layers to accomplish trust at each layer, and the other key thing you're seeing there, and trust, human trust is only accomplished, you can't accomplish it just technically, you have to have governance, you have to involve the humans. So that's why you see the governance stack on the other side, and the fact that it's a dynamic living thing. Governance, needs to evolve over time as both technology evolves and people and culture evolves. So that's this high-level picture. The key thing I want to point out to you is when you look at that 4-layer stack design, the essence of what made the internet so successful was the fact that it has a spanning layer, a single protocol in the center at layer 2. For TCP/IP, it's the IP protocol. And what made the IP protocol work was a new addressing scheme that worked across all the local area networks. That's the IP address, okay? When we started with Trust over IP, we said we need the same 4-layer stack and we need the same spanning protocol. And we knew this is a tall order, and we knew we were in this decade-long game to establish, define the stack and get it adopted. The good news is that trust spanning protocol at layer 2 is done. And the code now lives, there are 2 implementations, but one of them is at the Open Wallet Foundation. It's called TSP, the TSP project, and it's starting to get some serious scrutiny because, well, I'm just going to mention, besides the obvious problems it solves that we're going to talk about here, there are already implementations now that run the MCP protocol and the ADA protocol over TSP in order to give you a whole bunch of security properties that are not built into those protocols. So if we're talking about resilient digital trust infrastructure, I point you here and at the Trust over IP stack and TSP as the place to start. I'm the co-chair with two fantastic architects. I basically just, organize the meetings and carry their water for them. Wenjing Chu from FutureWay and Sam Smith from Digital Trust Ventures, who are the architects of that protocol. The secret to that protocol is the same as with IP. It was a new addressing scheme. The secret to this is verifiable identifiers. The identifiers that are connecting over TSP are both cryptographically verifiable identifiers. Now, the best known of that are called DIDs, decentralized identifiers. I was co-editor of that spec. 7 years of my life went in from starting that work, which interestingly enough was the original DID spec was contracted by the US Department of Homeland Security. This classic thing of, and let's invest in future infrastructure. And then it was a 7-year, all the way to becoming a W3C standard in 2021. The first addressing scheme approved at W3C since HTTP and HTTPS URLs. The only one approved, and believe me, I had a lot of dialogue with them about that over time. So this is a super key architectural point about decentralized trust, how it's going to work at scale. You have a separation between establishing cryptographic trust between essentially machines, right? We just simply call them verifiable endpoints, just the way TCP/IP could connect any two endpoints on the internet. We're saying with TSP, we can connect any two verifiable endpoints. And that means there's keys, there are cryptographic keys associated with both endpoints that you can resolve and verify are the keys for those endpoints. That's what DIDs and other forms of VIDs can do. Now, once you establish that, you have to go up to a higher layer to actually establish human trust. And the key technique, or the key tool for establishing human trust, not the only one, but the key one, is verifiable digital credentials, which is a separate W3C standard, the second generation of which was just approved. And then there's a role for what we call trust registries in verifying those credentials. So I just want to plant the key for that separation because it's key to everything we're going to talk about. This is what we call the upper half of the trust triangle, or the whole thing is the governance diamond for all types of credentials, but specifically digital credentials. You have an issuer of the credential, you have a holder that puts it in a wallet, right? And then you have the verifier of the credential. And if you want to scale a system like that and not limit it to a single issuer, then you get into having a governance authority and a governance framework for that trust community or ecosystem, whichever you want to call it. Best examples of that have scaled globally, Visa, MasterCard, the payment networks, where any bank can issue the credential, but they all do it according to a set of operating rules set by Visa or MasterCard or Discover. Or same thing actually applies to our passport system. Governing authority is ICAO. Every country issues interoperable passports under those. So that's the basic model of, once we move up to verifiable credentials, the basic model, trust model you have for that in digital trust ecosystems. And the last point I'm going to make about the building blocks is everything depends on the digital version of these wallets, okay? Now what's interesting there is you have one whole view of digital wallets in the Web3 and cryptocurrency side, right? They have advanced, the technology of wallets and the key management inside wallets, BIP32, the whole way you can have hierarchical dependent keys, and also usability of those wallets. I'm not rating them very high, but they have moved a long ways down the road. Meanwhile, you've got identity wallets that, like the EU Digital Identity Wallet or the Bhutan wallet, where it's all about the credentials that you're having issued and that you present. So I need to ask you, in the real world, do we distinguish between those two things? Right? It's almost entirely an artificial distinction, which we believe is going to go away. That the wallets that are evolving now are going to be tied to an agent, not necessarily an AI agent, although that will happen over time, and they will serve both of these functions. The first of these unified wallets are coming on the market, and I'm just suggesting to you that's what you're going to see with first-person credentials. All right, last piece of what I'm going to cover is, all right, so with those building blocks, what do we need to, to actually have this decentralized trust graph? And the credentials I'm going to talk to you about here are the ones we're developing right now in a working group I'll talk about, the Decentralized Trust Graph Working Group, Trust over IP, and we're already starting to implement them with the Linux kernel project. We're working with the developers and maintainers of that project to say, you're now going to have very simple digital wallets. They're not going to be, we're not proposing they all have to go out and download a new mobile app. They're going to be using a very simple CLI-based wallet that we're integrating right into their workflow, and this should be true for any Git or Git-based project. We're actually going. It turns out one of the reasons Jim wanted us to start with the Linux kernel project is they use Git, not GitHub, right? They wrote it, they still maintain it, and they said, if we get it integrated right into Git and replace the GPG web of trust they use today, then it will be something that any other project could adopt. See, he was thinking way down the road in terms of how this should work. And not just the Linux Foundation, by the way. He wants Eclipse, any open source supply chain. So the credentials I'll talk about here, it turns out we just need 2 types of credentials to build this trust graph, okay? We call it personhood credential, which is what that whole paper is about. Again, we didn't write that paper. There's a couple folks on our project now that were part of that, but they joined after we said, hey, we're going to go implement what you put in that paper. The second one is a credential format we had been developing at Trust over IP because turns out trust relationships, which can only be proved by the 2 parties to a relationship, are an enormous trust signal that don't come from just top-down typical authorities like passports or driver's license or typical government credentials or even corporate credentials, right? They give us the richness of the decentralized trust graph, just like you maintain your mobile address book and who's in it. So very quickly on those 2, I've already showed this before. If you want to go straight to that paper, you can grab that QR code. As I said, you can also just put personhood credentials into any search engine, and this is what comes up. Very widely referenced paper. All 63 pages I'm going to boil down to you to 2 points. A personhood credential is issued by an issuer whose governance says, I will only issue 1 to a unique human. I'll only issue to real people, and they must be unique. I'll only issue 1 to any human in my scope. So governments do this with government ID today. Corporations do it with employees. Universities do it with students and faculty and staff. Professional associations do it with members. It's a very common requirement to issue 1 per person for many different reasons, right? Voting and equal rewards and everything. So all we need to do, in some cases we can actually triangulate off those existing credentials, but as those issuers start to issue digital credentials, they fit perfectly in that. The second requirement that the paper goes into in great detail is if we're going to have a standard credential, we could use it any site to prove we're a real person, we're a unique person, set up an account or prove that we only have 1 account at sites that need that. We don't want that credential to be linkable across all those sites. It's the exact same requirement that's in the EU Digital Identity Wallet regulations, unlinkability of the credentials. Even though the first generation of the EU Digital Identity Wallet will not have $0 proof crypto, they can't decide on what ZKP was going to work. We have a commitment in the first person project to do it, and we're working with a team at the University of California, Berkeley, one of the top ZKP teams in the world on that, and Hart Montgomery we're already being asked to work with other projects that do want to also standardize on ZKP so that we can have it very broadly adopted. Go ahead.
It's written weirdly, verifiers must accept. It means that there are also other ways to identify yourselves which are not based on ZKP.
Yes.
Okay? So
Yeah.
why are there other ways other than, because if
Are you talking about the first-person project or digital wallets in general?
no, the first person,
Oh, no. In the first-person project, it will just be ZKP. Right. Other projects, I'm just saying there are many other ways that, again, that's part of the interoperability issues. But we're saying, okay, we believe, and there are a number of other folks out there that agree with us, that broad adoption of digital credentials, digital wallets, for privacy to be respected, we're going to need to standardize on ZKP for it. The EU has basically said, we know we have to go there. The technologists said we know how to go there. They're working on trying to agree on what that ZKP is going to be. And they've already, like I said, since we have committed to it, they're already reaching out to us saying, well, what are you going to do? And we're like, well, here's the options we're looking at. We haven't made a final decision. Again, that team, if anyone here is interested in that, let me know. I'm happy to, tie you into that work. So this is what we end out with is, in an ecosystem, the issuer simply agrees, I'm going to issue one per person, and if you lose a credential or something happens, you can get revoked and reissued, but still just one per person in that ecosystem. So that's the first one, and that gives you that strong, essentially, proof of personhood in that ecosystem, but it doesn't get into that richness of the other trust signals from peer-to-peer. And for that, we have the verifiable relationship credential. And this is where Jim used the analogy of, this is the modern version of the PGP key signing party. So I'm going to quickly, the most detailed slides I'm going to show you are the next two, and I'm going to say, well, so exactly how does that work? All right, so I'm going to break it into two parts. And the first part is, has anyone here at this conference already used a QR code to connect to someone else at the conference? On any system, LinkedIn or WhatsApp or?
this conference?
Yeah. Maybe not. Okay, but at conferences in general, it's becoming more of a standard, right? I actually don't even carry business cards now. I'll connect with you on whatever network you want. I prefer Signal for privacy reasons. But here's the point about that. When we connect with those QR codes, we're always connecting on that network. And even if I love connecting you with on Signal, and then if we decide, I actually want to have a meeting with you, what's your email address? I can't send you a calendar invite on Signal. Yet, anyway, okay? What we're moving into now, this whole infrastructure, and this isn't specifically the first-person project, is why aren't we connecting person to person, wallet to wallet, forming a connection, a cryptographically verifiable connection between us that we can use for everything, right? That belongs to us and not some network. So what we show here in the classic Alice and Bob scenario, I wonder if this, yeah, it does work, imagine Alice and Bob are meeting here at this conference. Alice pops open her wallet and produces a QR code. Bob scans it and says, yep, I want this connection. His wallet and the key pair, it's going to use what we call a self-certifying identifier. Based on that key pair, he produces the DID document that he then shares back to Alice using an address that was in that. Underlying protocol could be NFC, could be Bluetooth, it could be over the internet, doesn't matter. That's the first part of the connection. There's going to be a nonce in there, so Alice is going to verify, yes, that's actually a response to the QR code that I gave out. She's going to verify Bob's signature on that and do the same thing back in the other direction. What's just happened there is what we call pairwise pseudonymous DID exchange. That has created, the term we use is a personal private channel between those two parties. End-to-end encrypted for anything they need to use that channel for. Okay? And I want to emphasize that because there's a ton of additional value that can be added beyond just setting up trust relationships. But we're only going to cover that. So that's part one. And that, again, it's a matter of, you think about it, it doesn't have to happen by the QR code, right? Any way that original link can be shared. So it can happen person to person, it can also happen remotely. It does not have to happen with everyone in the same room at a party, okay? That's the first thing we can do. Now, part two is, again, this pink shaded up here is what we just did to create that channel. Now, the first thing we're going to do with that channel is Bob and Alice are each going to issue the other one a verifiable relationship credential. And the basic credential is extremely simple. It's got the two DIDs that they've just exchanged, a date stamp, and Bob signs his with his private key, issues it to Alice. Alice verifies that and does the same thing back to Bob. They're directional credentials, okay? Now, the only thing I didn't cover there is this thing called personas, because everything so far exchanged is just machine readable. It's basically two machines are saying, yeah, okay, we can verify this relationship with the other. But how do they prove that to anyone else? These are pseudonymous pairwise identifiers. That's what personas are for. And that's the last thing I'm going to cover in the building blocks part of this presentation. So, and I want to emphasize, so what we've just done is added this leg to this triangle. Now, because it would be actually trivial for two of us to create bots and exchange a ton of those verifiable relationship credentials to make them look like I have a bunch of relationships, the symbol protection is the zero-knowledge proofs prove you have a relationship in the context of an ecosystem in which you're both part of. For example, Linux Foundation, or a particular open source project, or a particular university, or a particular conference, whatever it is. That's how we get the symbol protection, so that you can only prove you have a unique relationship with another person in that context. Does that make sense? Yeah. Okay, so this is, again, the last thing I'm going to cover is, now how do you use this to actually control the personas you're sharing, your privacy, if I've set up those relationships and now I need to prove it to someone else, well, what can I prove? And this comes down to that persona thing, and I'm going to go to this last slide. I'm going to try and quickly cover this, okay? So this is a look. Imagine you're looking into your wallet, just like you're looking in your mobile address book. Well, your mobile address is just one flat set of numbers, right, and entries, okay? Now look in a digital wallet, you're going to have a bunch of key pairs in there, and they're going to divide into these two big buckets. This lower bucket is all of those pairwise relationship-specific identifiers, automatically created, automatically managed, and you never need to share them with anyone because they are always pairwise specific, okay? It's just for the integrity of those channels. The upper bucket, we call it personas even though it's an overused term, but the point is they are key pairs and identifiers that you use to control how you are known, how you can prove that you are the same person in any particular context. And we break them into these three buckets. Obviously, public personas, right? Whether you're an artist or an actor or a blogger or a politician or whatever, right? What's that? And open source. Oh, how could I forget that one? I should have started with that one. Although, I'll tell you why. Because we know that there's, developers we talk to on the kernel project, they want to control, okay, who knows that I'm doing this, right? So I usually actually use this second level to say, if you only want to be known in a certain community, you want to control that, okay, I'm the same developer on this project, or maybe I'm the same developer across all the Linux Foundation projects or all the open source I work on, it's still a community DID, okay? Because I want to keep that separate from my political DID or my sports DID, right? Or my sports persona, I should say that, okay? So fundamentally, personas are the way that we can start to prove, to control where we're known and be able to prove it and still control our identity in that context. The example we like to use, public persona for one of the best known artists in the world, Banksy. Banksy is famous for being a pseudonym, and he protects his pseudonymity very, very carefully. We know that because I wasn't even aware of this, but he is now aware of the First Person Project and is potentially interested in working with us to show how even he can now.
Can we be sure it's Banks?
We've actually been having discussions about that very point. How would you know it's him? You have to have people that you do say, I'm a real person and I know it's him. I have a connection, but I'm not going to tell you who he is, right? Just like I said with a mobile address book, it's a sensitive thing. So anyway, this is the point about personas, and specifically when it comes to community DIDs, how developers can control a persona that they want to share when they enter that GPG Web of Trust. And that's, again, I'm done with all the technical slides here. I'll hold off on this. Oh, look, I have 5 minutes left. That's perfect. I'll save it in this topic about how actually, it's so fast. I'll just show you. All this stuff we talk about person to person, these verifiable relationships can also be with anything else. It can be with a project, it can be with a business, it can be with a government, right? And it can be with an agent. Exactly this whole thing. If agents have the same ability to prove their identity, to have encrypted channels, and with this credential, you can actually prove the delegation. Now, we don't have the delegation semantics in there, but there are a bunch of working groups working on it. Once they come up with what that semantics is, you add it to that credential, and you've got a way of verifiably having, for instance, a personal agent. You can prove it's acting on your behalf and that you've delegated this information. And we have one of the folks leaning into our project called Affinity. They're funded by Temasek, the Sovereign Wealth Fund of Singapore, and they've been in the space for like 5 years, and now they're saying, okay, we're finally ready now to provide this infrastructure for both personal and business agents at scale. I won't go into the specifics, but again, you can share this diagram. They'd be happy to go over it with you. They asked me to present this at the Agentic Internet Workshop last week in San Francisco. So yes, all of what we're talking about can apply to personal and business AI agents as well. Now, I'm done. Q&A and/or dialogue about, well, how would this apply to your open source project or effort or infrastructure? Go ahead.
When you're talking wallets, my first knee-jerk reaction says, oh no, yet another crypto scheme. Is this based on the blockchain?
Zero.
So I suggest avoid using wallets, even though wallets, try any other term. Make sure you state that clearly.
You know what I probably should have said up front, because it's very difficult to avoid that term, but I probably should have put that right up front. You're absolutely right. You're very right. Yes, there's no, technically, your decentralized identifiers, you could use one that's based on, they're literally like 160 methods that are based on different blockchains. That's fine if the other party agrees, yeah, I'll accept that kind of DID. We actually promote self-certifying identifiers so you don't have to have any dependency on a blockchain. Yeah, so that's a very, very good question, and I apologize for not making that clear up front. Yes. On the other hand, if we introduced a token and everyone could adopt it, I mean, what? Yeah, no tokens. Go ahead.
We've been using Credo for a while, so it's part of the solution for the government wallet in Ireland. But I'm looking at this, so the relationship credential is really interesting one in the context of delegated authority.
Yes.
So I'm working in healthcare.
Oops.
So I want to get access to my mother's healthcare record. So that relationship is then a model of a relationship using those credentials. So I can build that relationship and say,
yes. So we talk about relation with agent as a kind of delegation. You can do delegation to agents and people.
we've been in it's like, because the typical solution at the government level is, we'll create a repository of all the relationships between all these people and who's delegated what to who, et cetera, but this beats the shit out of that.
Exactly. You can get all the cryptographic strength and verifiability you need without centralizing it.
Yeah.
I cannot emphasize that enough. Yes, 100%. Okay, we're almost there. So we have one more minute for additional questions. I'm going to be here during lunch if you want to dive down into anything, but any other questions I can answer? Go ahead.
How do we get started?
So I will say one thing. Because of that governance side of this, As we, actually, I'm going to go ahead just to put up one more cue. Why is this thing, sometimes it's working, sometimes it's going slow. I want to make sure that everyone knows there is this new, that's actually literally the charter of this new working group at Trust over P and DIF. It's a joint working group. That is where, in fact, this afternoon I have to go to chair for 1 hour at 4 o'clock. I have to go chair a call for that. That working group is defining these credentials and the trust hash protocols to do it right now. Meanwhile, code is already there's a Linux Foundation Decentralized Trust Code repository for the code they're creating for the kernel project, and a separate one for the ZKP that Berkeley's driving. So we need to finish these components, but our goal is by the next LF member summit, which is the end of February, February 23rd and 24th, also in Napa, California. We want to show it working and have Greg Kraut-Hartman stand up and go, yep, a year ago they said we were going to do this, we've done it. At which point, then we're ready. Now you understand Jim's thing. Oh, now LFX could integrate it right into GitHub. And once LFX has done that, any Linux Foundation project will be able to use it. You can see why at the first person project we were pretty ecstatic about this. It's like, okay, that's a great adoption vector. By the way, it's not the only one. The other two things, events like this one. Imagine if all of us had first-person enabled wallets and everyone you met here, you could do a QR code, and that relationship was not limited to this event, but you could carry it forward any place you wanted. The last one is universities. I'm looking at my friends here from the university professors that I met in China. That's also, guess what social network started at certain universities? I'll mention one more thing. Some of our biggest collaborators right now are from the Harvard Applied Social Media Lab. And they see this as, hey, this is where social media needs to go. I know we're out of time. Yeah, we're getting the hook here. But thank you very much. And again, I'll be here for lunch and as much of the rest of the day as I can, except for that one section I have to step out for. Super. There's the QR code if you want to join that working group.